You type a few words, hit enter, and get answers from billions of pages in under a second. But what actually happens in that fraction of a second? When you type a query into a search bar, you're not just sending words into the void. You're initiating a deeply complex, lightning-fast dance involving billions of web pages and complex algorithms. Understanding this process isn't just for tech enthusiasts. It's important for anyone trying to get their content discovered or simply navigate the web effectively. Today, we're going to break down the entire life cycle of a search query, from the moment you hit enter to the results appearing on your screen. We'll look at the actual systems that discover, organize, rank, and present the vast information of the internet and see how it all fits together. Crawlers discovering the web. Before you can even search for something, a search engine needs to know it exists. This is where web crawlers, often called spiders or bots, come into play. Think of them as tireless digital explorers, constantly traversing the internet, following links from one page to another. Their mission is to find new web pages, identify updates to existing ones, and bring all that raw information back to the search engine servers. It's a never-ending process, given how dynamic the web is. Every second, new pages are published, old ones are updated, and some disappear entirely. Without these crawlers, the search index would quickly become outdated, making finding current information nearly impossible. They don't just visit a page. They download its content, looking for text, images, and other media, essentially taking a snapshot of the page at that moment. This initial discovery phase is fundamental, setting the stage for everything else that happens in the search process. They are the eyes and ears of the search engine, working in the background, out of sight, but essential to our daily digital lives. So, how do these crawlers know where to go? They don't just randomly guess URLs. Their process starts with a seed list of known URLs, and then expands by following every link they find on those pages. It's like a digital breadcrumb trail. Websites also help them out with sitemaps, which are XML files listing all the pages on a site, essentially giving the crawler a detailed map. On the flip side, robots.txt files tell crawlers which parts of a site they should not visit, preventing them from indexing private or irrelevant sections. This combination of following links, respecting instructions, and consulting maps allows crawlers to efficiently navigate the scale of the internet. Without these protocols, crawlers would either get lost in endless loops or waste resources on insignificant pages. Consider it as a delicate balance between giving crawlers enough freedom to find new content and providing enough guidance to keep them from getting bogged down. This structured approach is what makes comprehensive web discovery even possible at such an enormous scale. The sheer scale of the web is staggering. Estimates vary, but we're talking about hundreds of billions, possibly even trillions of unique URLs. A single search engine can index a significant portion of this. Imagine the infrastructure required to not only visit these pages, but also to process and store their content. It's not just about finding static HTML pages. Crawlers also need to handle dynamic content, JavaScript render pages, and various media types. Keeping this enormous index fresh and relevant is another challenge. New content is constantly being published, blog posts, news articles, product pages, and crawlers prioritize frequently updated sites or pages known to have fresh information. However, less popular pages might be revisited less often. This constant balancing act ensures that when you search, you're getting the most up-to-date information possible, rather than stale, irrelevant results. It's evidence of the engineering behind these systems that they manage to keep pace with the ever-expanding and evolving digital universe. Indexing, organizing the information overload. Once a crawler brings back a page, the real organizational work begins. Indexing. This isn't just about storing the raw HTML. It's about parsing the content, understanding its context, and extracting crucial information. The search engine reads the page, identifying important keywords, headings, image descriptions, and even the language. It analyzes the text for themes and topics, trying to grasp what the page is truly about. This involves advanced natural language processing techniques to differentiate between meaningful terms and common stop words like the or. For example, If a page talks extensively about neural networks, the indexer recognizes this as a core topic. If it mentions Apple many times, it needs to figure out if it's about the fruit or the technology company. This parsing and analysis process is critical because it transforms a jumble of raw data into structured, searchable information, making it possible to quickly find relevant results later. It's like turning a giant library of uncatalogued books into a perfectly organized system where every book's content is summarized and cross-referenced. The heart of a search engine's ability to retrieve information quickly is the inverted index. Instead of storing pages and listing the words on them, an inverted index stores words and lists all the pages where those words appear. Imagine a giant dictionary where each word entry doesn't just have a definition, but a list of every book and page number where it's mentioned. When you search for quantum computing, the search engine doesn't scan billions of pages. It instantly looks up quantum and computing in its inverted index, retrieves the lists of pages associated with each, and then finds the intersection of those lists. This dramatically reduces search time. Beyond just the word itself, the index often stores additional information, like the word's position on the page, its frequency, and whether it appeared in a heading or bold text. This extra metadata is vital for ranking relevance, as a keyword in a title is usually more important than one buried in a paragraph. This advanced data structure is what makes near-instantaneous search results possible. The web is not static, so the index can't be either. Keeping the search index fresh is a continuous and complex operation. As crawlers discover new pages or updates, these changes need to be reflected in the index. For highly dynamic sites like news outlets, updates might happen almost in real time. For less frequently changed content, updates could be slower. This process involves adding new entries, modifying existing ones, and removing pages that no longer exist or are deemed irrelevant. Search engines employ complex algorithms to prioritize what gets updated and when, balancing the need for freshness with the immense computational resources required. A stale index leads to bad search results, showing outdated information or broken links. The goal is to strike a balance, providing users with the most current and accurate information without overwhelming the system. It's a massive, distributed database operation running 24/7, ensuring that the digital library remains not just organized, but also current. Ranking, deciding what's best. Now that we have a massive, organized index of web pages, how does the search engine decide which ones are most relevant to your specific query? This is the art and science of ranking. Relevance is the first crucial factor. It's not just about whether a page contains your keywords, but how often they appear, where they appear, in titles, headings, body text, and how closely related the surrounding text is to your query. The search engine tries to understand the true meaning and context of your search terms. If you search for best coffee maker, it won't just look for pages with those exact words. It will also consider synonyms, related concepts, and pages that demonstrate expertise in coffee appliances. Modern ranking algorithms are incredibly advanced, using machine learning to weigh hundreds, if not thousands, of different signals to determine how well a page matches your intent. This ensures that the results aren't just a jumble of pages containing your keywords, but a carefully curated list designed to answer your question effectively. Beyond direct relevance, a page's authority plays a massive role in its ranking. Think of authority as a measure of trustworthiness and credibility. The most well-known signal for authority is backlinks, links from other reputable websites pointing to your page. If many respected sources link to a particular page, it suggests that the page contains valuable, authoritative information. It's like a vote of confidence. Search engines analyze the quality and quantity of these backlinks, considering who is linking, not just how many. A link from a major news organization carries more weight than a link from a brand new, unknown blog. Other authority factors include the domain's age, its reputation, and consistent positive user engagement signals. The goal is to surface content from reliable, expert sources rather than misleading or low-quality sites. This is why building a strong web presence with valuable content that naturally earns links is so important for visibility in search results. Ranking isn't a one-size-fits-all solution. It's highly personalized. Search engines try to understand your user intent, what you're truly looking for when you type a query. Are you looking to buy something, learn something, or navigate to a specific website? The algorithm attempts to infer this from your query, your location, your past search history, and even the time of day. A search for pizza will yield different results if you're in New York versus Rome, or if you've previously searched for pizza delivery near me. This personalization, combined with advanced machine learning models, allows search engines to continuously refine their ranking algorithms. These models are constantly learning from billions of user interactions, adjusting the weight of different signals to improve the quality of results. It's a dynamic, evolving system, always striving to deliver the perfect answer, tailored just for you. This continuous feedback loop ensures that search engines remain highly effective even as information and user behaviors change. Query processing, understanding your intent. You've typed your query and the ranking algorithms are ready, but first, the search engine needs to make sense of your input. This is query processing. It starts with basic analysis, checking for spelling errors, correcting typos, and sometimes even suggesting alternative phrasing. If you type, "how to bake a cake," the engine understands you mean bake and adjusts your query before searching. Then, it considers synonyms. If you search for car, it might also consider automobile or vehicle to broaden the scope and ensure you don't miss relevant results. This initial analysis is crucial because even a small misunderstanding of your query can lead to completely irrelevant results. It's an intelligent interpretation layer between what you type and what the search engine actually searches for, designed to maximize the chances of finding exactly what you need, even if your input isn't perfect. This process relies heavily on vast linguistic databases and machine learning models trained on countless queries. Beyond simple corrections, search engines employ query expansion and natural language processing, NLP, to truly grasp your intent. Query expansion involves adding related terms to your original search, even if you didn't explicitly type them. For instance, if you search for healthy recipes, the engine might internally expand that to include nutritious meals, diet food, or low-carb cooking, to ensure it covers a wider range of relevant documents. NLP allows the engine to understand the relationships between words in your query, not just the words themselves. It can differentiate between apple pie recipe and apple stock price. Understanding the context changes entirely. This is particularly important for conversational or long-tail queries, like, what's the best way to clean rust off old tools? NLP helps break down these complex phrases into their core components and intent, allowing for more precise and contextually appropriate results. It's a significant leap beyond simple keyword matching, moving towards a true understanding of human language. Once the search engine has a clear, refined understanding of your query, it's time to match it against the vast inverted index we discussed earlier. This is where the power of quick retrieval happens. The engine rapidly identifies all the documents that contain the keywords, synonyms, and expanded terms from your process query. It's not a brute force scan. It's a highly optimized lookup operation. The result is a preliminary list of potentially relevant documents. This list can still be massive, containing millions of pages. This is where the ranking factors from the previous chapter kick in. These preliminary matches are then filtered, sorted, and scored based on relevance, authority, freshness, and personalization signals. The combination of efficient index lookup and multi-factor ranking algorithms allows the search engine to narrow down those millions of possibilities to the handful of highly relevant results you see on the first page, all within milliseconds. It's evidence of incredible engineering that this complex process feels instantaneous to the user. Presenting results, speed, and user experience. After all that advanced processing, the final step is to present the results to you in a clear, usable format. This is the search engine results page, or SERP. It's not just a list of blue links anymore. Modern SERPs are rich with various elements. Snippets that summarize the page content, knowledge panels providing direct answers, image and video carousels, local business listings, and even interactive tools. The search engine carefully crafts these results to give you the most information at a glance, often answering your question directly without needing to click through to a website. This is particularly true for informational queries, where a quick fact or definition might be all you need. The presentation is designed for optimal user experience, prioritizing readability and speed. Every element on the SERP is strategically placed to help you quickly identify the most relevant information and decide where to click next, or if you even need to click at all. All of this complex work, crawling, indexing, ranking, and query processing, happens in milliseconds. The speed at which results appear is a critical factor in user satisfaction. To achieve this, search engines rely on a globally distributed infrastructure with massive data centers located around the world. When you type a query, it's routed to the nearest available data center, minimizing network latency. These data centers house enormous clusters of servers, optimized for rapid data retrieval and complex computations. Caching mechanisms also play a significant role, storing frequently accessed data closer to users for even faster delivery. The entire system is engineered for resilience and redundancy, meaning if one server or data center goes down, others can pick up the slack smoothly. This backend machinery is what powers the seemingly instantaneous responses we expect and often take for granted every time we search. The search engine's job isn't done once results are displayed. It continuously gathers feedback to improve its algorithms. Every click, every refinement of a query, every time you quickly go back to the search results page after visiting a link, these are all signals. If users frequently click on a particular result and stay on that page, it's a positive signal. If they quickly pogo stick back to the SERP, it suggests the result wasn't satisfactory. This user interaction data, combined with manual quality ratings from human evaluators, feeds back into the machine learning models. These models then adjust the ranking algorithms, making them smarter and more accurate over time. It's a constant cycle of learning, adapting, and refining, ensuring that search engines remain highly effective even as the web evolves and user needs change. This relentless pursuit of the perfect answer is what makes search engines such a critical tool in our modern lives. Still with me? Good. The best part is coming up. Web crawlers tirelessly discover and update web pages. An inverted index organizes content for lightning-fast retrieval. Complex algorithms rank pages based on relevance, authority, and personalization. Query processing understands user intent, correcting typos and expanding queries. Results are presented rapidly on a rich SERP, constantly refined by user feedback. Search is a complex, multi-stage process, not a simple lookup. Relevance and authority are important for content visibility. Search engines are continuously learning and adapting to provide better results. Your interaction with search results directly contributes to their improvement. Understanding how search engines operate gives you a huge advantage, whether you're trying to get your own content found or just navigate the internet more effectively. What part of the search process surprised you the most? Let me know in the comments below.